Hello and welcome to Component Rescue Board Repair. So tonight we're going to be working on an 820-3115 with no power. So before I started the stream I just quickly looked over this board and it looks like this board has already been ultrasonicked, but there still is a little bit of corrosion left and some obvious evidence of it too in a few places. So I'm going to go ahead and go to those places so we can take a quick look. So let's switch over to the microscope. So this place right here is going to be one of them. Look at that. That's not very pretty. That's not very pretty at all. We're definitely going to need to fix that. Which on this board, I believe that little area that's all corroded right there is going to be the circuit that makes PP3V42. And then also on the other side of the board, over here, let's get that in focus, looks like there's quite a bit of corrosion here and there's actually a little component that's knocked off. And I'm pretty sure this is audio stuff right here. It's part of the audio circuit. I don't know if you guys can see, but actually right there, I don't know if it was in the ultrasonic or whatever, but that little component got knocked off. And this one's still completely covered in corrosion. Like look at that. Look at that. That is just gross. But anyways, let's go ahead and get started on this. So okay, we got the power supply turned on, and we'll go ahead and plug this in and see what we get. So it looks like we get no light on the charger, and we are drawing 0.00 amps, which means that that corrosion around the PP3V42 circuit right over here is definitely keeping the computer from turning on. So let's go ahead and get this fixed and see where that gets us to. So this area right here is a little bit tricky to work with since it's right next to the RAM slot. You got to be careful when using hot air to make sure that you don't melt the RAM slot right here, because if you melt this or you get this too hot, there's a whole bunch of little pins under there that'll go bad, and there's not really a good or easy way to fix that. So here's my tweezers. Go ahead and get our hot air turned on. And you also want to be careful too, because right there, that's a CPU, there's a RAM slot, and your PCH, or actually that's not the PCH, this is the camera chip, is right there too, all right around this one little area. So you got to be very careful of where you direct your air. So I'm going to go ahead and get some of these components pulled off, like this one right here. Well, let me kind of re-angle this a little bit, maybe make it a little easier for me. There we go. And we'll get that all back in view. So we're definitely going to want to replace this chip right here, since it's covered in corrosion. I don't think this chip actually has anything to do with the PP3V42 circuit, but I can't entirely remember. But since it's completely corroded, we're going to want to replace it anyways. We'll go ahead and pull off this cap, and we'll pull off this cap. Oh, that one's just going to fly away. And we'll go ahead and pull off the PP3V42, which looks like that is all corroded. Ooh. And we'll go ahead and grab this diode and put that back where it goes, right there. And something I just touched, super hot. Is it the heatsink maybe? No, the heatsink's a little hot, but it shouldn't have burned me. Maybe I accidentally touched my hot air gun. Yeah, it's probably gonna blister. Oh well, we gotta continue working. So, now that we got all of that crap off of there, we need to get this all nice and cleaned up, which I'm gonna grab this cat from over there. So let's go ahead and add some flux. Man, that really burns. Add some flux there, and over here. God, that hurts. Okay. And then we'll grab our soldering iron and we'll go in and get that all cleaned up. Oh, that's kind of out of view for you guys. There we go. So this pad right here, we're going to have to kind of scrape at it a little bit so that we can get the solder to go back on there. There we go. And since this was all pretty corroded, we'll definitely want to go ahead and wick all of that away to get all of the corrosion off of there. Yeah. So let's get us some nice fresh wick. There we go, there's some wick. Oh, come on. I really need to get me some better wick. This wick works okay, but it really just isn't my favorite. But I still got quite a bit of it left. I don't really want to waste it. And like I said, it works okay. It's just not great or anything. Okay. There we go. That's all nice and cleaned up. I'm going to go ahead on this little capacitor right over here. I'll just go ahead and add a little bit of solder just to make those joints look nice. And now we'll clean all this off. Okay, there we go. That's all nice and clean now. Let me make sure. Yeah, that all looks bueno. Hopefully we won't have to run any wires here. It's looking like everything will be fine though. Hopefully it will. So let's go ahead and add some more flux to all of this. And then we can we'll put our solder on and then pull out a donor board and start transferring components over. Looks like we need a little bit more flux right over here. And then we'll go ahead and add some to this pad right there. Beautiful. Okay. So then I'll go ahead and grab one of my donor boards. Here's the donor board I'll be using. This was kind of one I just practiced fixing. It was, yeah, it was pretty bad. But it turns on. Not anymore though, not after we rip all the stuff off of it. But this board has no Ethernet or Thunderbolt on it, and one of the USB ports is destroyed, so you can't plug anything into it. Like, the port is physically destroyed, and this board just isn't worth fixing. So that's just one of the places I get my parts boards from. Some of them are just ones from China with holes drilled in them, but this one is just a regular old board. Let's go ahead and pull a part off. Okay, there we go. And now the tricky part is putting this back on here. This is not a very good view. There we go. Oops. I just knocked something off of my donor board, but that's okay, because it's a donor board. Okay, so now that everything's on there, did I get? Yeah, I got everything on there. So now that we got all the new parts on there, move the donor board out of the way, and we can add some more flux, and then get everything flowed properly into place. Oh no, when I knocked the diode off of my board. How could I? Oh no, little diode. Where did you go? Oh well, I may just have to get me another one. That's okay, I have more. Maybe it's on the board, maybe I got lucky. I doubt it though. It probably got sucked in to my air purifier. Oh well, I'll just have to get another one in just a moment. So let's go back to here. And as you can see on this board, it's really hard to solder over here without melting this at all. That's a little melted, but not to the point where it'll actually impact it at all. Let's go ahead and add some more heat, and we'll press down on this chip, get it soldered into place. And then we'll do the same. Actually, I'll clean that chip up first. And of course, this is completely crooked on there. That's okay, because we'll flow it into place once we get all of the extra solder pulled away. And now the hard angle is getting this from the back side. There we go. So now we'll do the same with the soldered chip. And we'll add a bit more flux. Clean off our soldering iron tip. And then we'll go in and touch all of these up. Come on, stop it. And to get this other side, I'm going to have to turn this a little bit. Okay, there we go. And now, of course, I gotta put diode back on. Excuse me. Where? Here we go. Here's one that still has the diode on it. There we go. I'll go ahead and clean those pads up. Oh no, we got too much solder. That's okay. There we go. Okay. Now we'll get the diode pulled off of this other board and we'll stick it on here. Okay, there we go. And there, we got the little diode back on there. Beautiful. And of course, all of this flux will be cleaned off when we run this through the ultrasonic afterwards. So there's all of that. So now, before I even test it, I'm going to go ahead and clean up this other side too, since I already know I'm going to need to replace these components. Okay, we'll move the board we're working on to this side for this, since this is on the far side of the board. So, looks like the actual balls on that little chip are pretty good. So I think we're just going to need to replace those components right above it that look like crap. And is this probe point gone right here? Nope, that's still there. Is this one still there? That one's still there. That one's still there. Which this component I think may actually be fine once we get all the corrosion off of it. Is this point fine? Yep, that one's fine. So I think we'll just need to replace that little component right there. So let's go ahead and add some flux. Okay, there we go. And we'll go ahead and pull that component off our donor board. That is right here. Okay. There we go, beautiful. So now the we got all the crap replaced that looked like someone took a dump on it. Now, hopefully we'll have a working board. So I'm going to do a quick inspection. Aha! There's where my little diode went. I'll just stick that back on the donor board since that diode's probably fine. Okay. Should be cool enough to test out now. So, I'm going to take a look over this real quick just to make sure that all of this looks good before we put power to it. Just want to be sure. Okay. That all looks beautiful to me. A couple of things are a little crooked, but that's okay. We can clean that up afterwards. So let's plug it in and see what we get. Okay. So I plug it in with the power supply and we're drawing 0 amps and get no green light. What about with an actual MagSafe? Still nothing. Nothing at all. So let's look back at this. Maybe it was just a bad soldering job. Well, I guess I can try cleaning that up a little bit. So let's just add some more flux to all of this. Some fresh flux. And then I'll kind of just reflow all of this back into place. And we'll see if hopefully that'll fix our issue. And I'll also make sure that these two chips are nice and pressed down firmly onto the board. Looks like that one wasn't down all the way. And then I'll do the same for this other chip right here. Just to make sure that it's properly flowed into place. Okay, there we go. Oh. Okay, there we go. Now that that's in place, I'll press down on it. There we go. So maybe that chip just wasn't soldered on properly. But looks like it's bueno now. See all of that over there. That all looks fine. A little bit of a glob on the end of that. There we go. Yeah, this is all looking pretty sexy. I mean, this over here looks a little sketchy maybe, but We'll see if maybe I just needed to reflow that to get it all working again. Let's see, what temperature is this all at? I have my little heat gun or heat reader thing saying it's at 75 Celsius. It's a little too hot to turn the computer on immediately. I usually like to be a little cautious just to make sure that nothing gets damaged. Usually once it gets to around 50 to 60 degrees, I say, hey, it's fine to turn on. Okay, there, we're at 60 now. That still is quite a bit warm, but that's an acceptable temperature to try and turn the computer on. Okay, let's plug it in. Aha, now we're drawing 0.02 amps. It's not giving me a light. Let's turn my hot air gun off so it's not so hot in here. Not getting a light on my fake MagSafe. What about my real one? Do I get a light on there? Nope, we get no light on the real or fake MagSafe. Oh. Aha, no wait, we do get a light. Look at that. We get a light, but there is still no fan spin, and my power supply said this was only drawing 0.2 amps, so looks like we're gonna have to keep going and figure out why this isn't turning on. Now, drawing only 0.02 amps is quite annoying because that usually means that the board is going to be missing PM Sleep S4L. But let's see if maybe it's something else. Okay, so first thing I'm going to check is I'll put my multimeter into voltage mode, and I'm going to check PP bus G3 hot. See what we're at there. We're at 12.6 volts, so that's good. Why don't I just go ahead and jump straight to it? Let's see, that is my board view. So here's the board view for this. We'll just go ahead and jump right to PM Sleep S4L, which this is going to be a signal that is required for the computer to turn on. So what this signal does is whenever the computer's putting out this signal, it basically says, okay, I've finished turning on to an S5 state, now go to an S4. So whenever this signal is missing, the computer will not turn on past an S5 state. So let's see what this is reading at, which, just like I thought, it's reading at 0 volts, which means that this is not going to be a fun board at all. So let's see, what were all those things that I replaced over there? So PP3V3, aha. This signal right here is a very important signal. SMC PM G2 enable is going to be the signal basically that tells the computer to go into an S5 state. So, and like I said, that's that right here. So let's go ahead and check. I can basically check if this signal is present to see by seeing if the S3 or PP3V3S5 or PP5VS5 are present on this board. So PP5V S5. Actually, that's not a good one. PP3V3 S5. That should give me quite a few places to test. Where can I find this? I can find it on this resistor right over here, which is right here. And it looks like we're not getting that signal. Which, this is never going to be fun. So, let's go ahead and find where the little test point is for SMC PMG2 enable, since that's going to be the signal that tells the computer, okay, you can turn into an S5 power state. So, let me switch back over to the board view. There we go. So it's showing there's a test point right there. Is that actually on this side of the board, or is it on the other one? Looks like that's going to be on the other side of the board. So we'll go ahead and flip it over. Which, this is not a good sign at all, since the PP3V3 circuit was messed up, and this signal is probably not going to be present. Let's see, where is this? This is, of course, underneath the heatsink. Where else would it be? Here we go. So if this signal is not present, then there's a very good chance that we have a bad SMC. Which, if that's the case, that's not going to be fun at all to fix. But I may still go ahead and show it on stream. Which, I'm going to go ahead, I gotta take my microphone off. I'm going to go ahead, actually I don't, I bet I can reach it from here. I'm going to get my ultrasonic cleaner turned on. And let that start warming up so we can get this board. Come on. There we go. So that way we can get this board cleaned off, and also if we need to reball the SMC, that'll make that a little easier too. Okay. So let's go back to the board. So let's see, this is going to be, gotta grab my probes and plug it back in. That's going to be right there. And we are getting, oh, interesting. We're actually getting 3.45 volts, which is close enough. So that's good to know that that signal is actually present, which means that the SMC is turning on. So then are we having an issue with this over here? So PP5V3V3 reg enable is going to be the signal that tells PP3V3 and PP5V, or PP3V3S5 and PP5VS5 to turn on. So let's go ahead and plug this in, and we will test over here to see if they are present. Let me see if I can get you guys in on this. That's going to be right there, which looks like we're getting 3.45 volts, which of course is close enough. So that means that that signal should be turning on. So let's go back over to the board view, since that's usually a little easier for me. So that's going to go into right there. So let's see if maybe this resistor is blown. Let's check the other end of that since I just checked one end. And we're getting 3.44 volts, which is good. So let's go ahead and check PP5VS5 and see if it's just PP3V3S3 that's missing, or if it's both of these, which, I think I may know why it's missing. I wonder why that could possibly be missing. It couldn't possibly be because someone's worked on this board before me. Yeah, because that's not even close to where I was just working. That chip is definitely not in the right spot. So yes, believe it or not, if you solder a chip on the wrong pins to the wrong thing, it will not work. So we'll go ahead and get the fan taken off so we can solder right there. I'll zoom back out. I mean, look at that. Like, what? Who the hell thought that this was actually a good soldering job? I mean, it looks like it's on there, kind of, but at the same time, like, well, why? I mean, that just looks awful. It's not even kind of straight. So, let's go ahead and get this fixed. I don't know if this is going to be what's causing it not to work, but we definitely cannot just leave that there. That is all kinds of wrong. Ugh. Why would someone do that to this poor little board? Why would someone do that to this poor little board? Let's just go ahead and get this straightened out. And hopefully this will fix the problem. There we go. That looks pretty darn straight to me. Hopefully this chip is still good. And whoever sodomized it, the soldering job beforehand didn't kill it. But I guess we'll find that out in a moment. Man, that's pretty hot. So I don't know if you guys can see that, but now see how that's straight? See how it's straight and that you can actually see all the pads? That's what it's supposed to look like, not whatever that completely crooked mess was earlier. I mean, if it's a little crooked, I mean, it'll be fine. But for something like this, no. No. You can't just leave it that crooked and expect it to work. Okay, we'll stick the fan back on it. And hopefully now it'll turn on. Oh, we still get no fan spin. Did we get anything at all? Come on. Come on, give me something. At least give me a partial fan spin. No, you're giving me nothing at all. No. Okay, fine. I guess I'll go back to actually testing all of these parts, seeing if they're good. So like I said from the stream yesterday, like I would ever get an easy board. This is just karma for what I said yesterday. This is totally karma. Okay. So let's see what we have for PP5V S5. We have 5 volts. So what do we have for PP3V3 S3? Where does that even come out? I'll just search for it. PP3V3 S5. Okay, so I can find that right over here on this cute little resistor. So what are we getting for you now? Still 0 volts. Where are you created? You are created. Let's see if I can remember this. Is it on the other side of the board, maybe? PP3V3S5LL. Okay, so that comes from there. Okay. So, first, let's see if we have a short to ground. We have a... here. So you guys can hear it. we have a 0 ohm short to ground. So let's see if we can figure out what is shorted to ground, since there are quite a few things on this line. Okay, so let's take a look at this area under the microscope and see if we notice anything. That's gonna be... Come on. Oh, it switched you guys over. Sorry about that. That is... Where are we looking? There we go. Right there. So right here is going to be the PP3V3S5 buck converter. Okay. So what I'm going to do is I'm going to remove this inductor right here so that I can figure out where exactly the issue is, and I think I can already probably figure out where the issue is, since I don't know if you guys can see, but there's some corrosion right there, which means probably something in this area over here died. So let's go ahead and figure that out. So let's get this inductor pulled off of here. Come on. There we go. Come on, tweezers. There you go. So this inductor does take quite a bit of heat to get it off. There we go. So now that that is pulled off of there, I can check to see where the short is. If it's on the side of the circuit that creates PP3V3S5, which it isn't, or of course the side where PP3V3S5 actually goes to. Okay, so that's right there. So, since I have corrosion right there, that leads me to believe that there's a possibility that something over here is bad. But what I'm going to do, I may have to come back to this board actually. Aha, here we go. I've been looking. Nope, that's not it. Okay, let's see. So I'll actually be back in just a second. I think I moved my my thing, my little wires to hook up to my power supply. So I'll be right back. Okay, there we go. Got the little probes here. So I'll go ahead, we'll lower the voltage down quite a bit. Actually, I'll turn it off. And I'll take my little charger off of there. And we'll just have this hooked up to it. So see these little wires right here? I have these going to my power supply. And then I have this wire here that I'll solder onto the board. And I may have to let this board cool off for a little bit before I can do this. But once I solder this onto the board, I'll just put some power into it. And then whatever heats up will be what has the short in it. Hopefully something will heat up. I know I've tried this before with you guys and nothing heated up, but usually on these boards the short will show itself. Come on. Get soldered on, you piece of crap. Well, it's a pretty crappy solder joint right there, but it'll have to work. Actually, let's try adding a little bit of flux. Solder. Yeah, that's good enough. Okay, and we'll turn the power supply down. And there's still a few things over there that are a little warm. So I may just let those sit for a second. Or another thing I can always do is I could always just add some alcohol and see what the alcohol evaporates. But to do that I need to clean the flux off. Okay. And everything's mostly cooled off over there, so we'll go ahead and turn the power supply on. And I'll start turning the voltage up. We'll put it at 1 volt. Okay, so at 1 volt. At 1 volt, we're drawing 0.65 amps. So I'm going to go ahead. I'll turn that off for now. So I'll go ahead and put a little drop of alcohol. Which nothing over there seems to be evaporating the alcohol, which leads me to believe that nothing over there is going to be what's causing the problem. So it looks like over here is just a whole bunch, excuse me, pull-up resistors. So let's see, on this side of the board, it could also be the clock chip. Is it the clock chip? No, it doesn't feel like it is. It may be though. Let's see. It could also be this area underneath the PCH. Okay, good, it's not the PCH. Okay, looks like it's not that area either. Where else do we have something that goes to ground? We do over here. Aha, it could be this chip that we soldered on. I don't know, that solder job looks pretty darn good. Is that heating up at all? No. Could it maybe be something on the other side of the board? Maybe this is going to be one of those not fun at all things to fix, because I always seem to get those. So I'll turn the power supply off so I can flip the board over really quick. Ugh. Ooh. Could this possibly be it? That looks pretty corroded right there. But I honestly think it's fine. looks like the camera's a little out of focus for you guys. There we go. See, I was looking at this component right here. See how you can definitely see it's kind of corroded? That one over to the right. Let's get the power supply turned back on. And let's see if anything heats up. Let's raise the voltage a little more. We'll go up to, we'll do like 1.5 volts. Grab me a glove so I can feel around the board without accidentally shocking myself. So I'll go ahead and get this going to 1 volt, or not 1 volt, but 1 amp. And then I'll feel around to see what's getting hot. Because something should be getting hot. Oh. Is it something in this area right here? Maybe? What is right there on the board? Let's switch over to the board view. That area is going to be this. Do we have anything here? No. Except this cap right here. Is it that cap right there? Let's raise. Let's use our heat thing to see what, if anything, is heating up. And for this, I definitely want to get my light out of the way. Since that does make some heat, it can interfere with this. So maybe this one is going to be an awful one to fix. Because of a short that does not want to show itself. Okay. What if I pump this up to 1.5 amps? feeling anything. Is it maybe... Here, let me give you guys something to look at. Yeah, I guess we can do that one. Let's go back to this other side of the board. Man, you guys can't see that very well. Let me zoom out a little bit so you can at least kind of see it. Let's just go ahead and start putting current back through this. Something just tells me though, something is messed up with this chip. Do you know what? Just to humor myself, what if, let's unsolder these wires temporarily, hopefully permanently, but maybe just temporarily. And I'm gonna try to see if I can touch this chip up anymore. I mean, it looks pretty darn good, but maybe it's not good underneath. But I just want to go after this first, since it's something that I touched. So maybe I messed it up, or maybe there's just something else dead on the board. Hopefully it's this, and we can be finished with this board for good. So it looks like that comes from a point on the other side of the board. I have no idea which one though. If I had to guess though, I could probably figure it out. Okay. I'll add a little bit of flux, and then I'll touch this up with the iron, and hopefully it'll be working. Oopsie, I accidentally touched the RAM slot. Oh well. Okay, so now plug this back in, see if it hopefully works. And wow, would you look at that, it doesn't. What a surprise. But not really. Well, actually I guess it wouldn't work even if the short is fixed, since I took the inductor off. So, actually I'll test to see if there's still a short. Okay, that's on. And of course there's still a short. Man, this one just does not want to be easy. You know what I'm going to do? I'm just going to take a random guess and go after this little cap right here. Since this cap is a different color than all the rest of them, maybe it's bad. There's only one way to find out. Man, wouldn't that be nice if that was the case? Wouldn't that be nice? I bet it's still shorted though. I'm not that lucky. Oh! Or maybe that was the case. Aha! We found the short. So, I guess I'll go ahead and just... Here. We'll get that all nice and cleaned up. See, sometimes if you really can't figure out what component is shorted, let's get that in focus. Sometimes you can just go around and look at the components and be like, all the components in this area, or all the capacitors in this area, are this color, but this one's a different color. I mean, you can't necessarily say all the capacitors on the board are this color, but this one's a different color, because, I mean, just the components will change color depending on how much they've been heated and how long they've been heated. So, in different areas of the boards, you get different amounts of heat. But if you're looking at the same area of the board, and there's components different colors, then you know something's messed up. So that's what I had to resort to in this case. But it ended up helping me figure out what the issue was. So let's get this inductor soldered back on here. Okay. And now let's steal my little replacement capacitor. Wait, is this the right board? Yeah, I guess it is. Come on off, little capacitor. It's time for you to be used on a beautiful working board. Or really soon to be working, I guess. Now let's get this inductor properly soldered on here. And I'll let that cool off for a moment. Okay, let's get the hot air turned off, and I may as well go ahead and put the heatsink back on. I mean, I don't actually know if this works yet, and I bet putting this back on is totally going to jinx me, but I don't want to accidentally stick my hand in thermal paste again, so I'm going to do it anyways. Which, of course, after this is done, it's going to have to get run through the ultrasonic, since it still had some corrosion on it, even after whoever had this before me ultrasonicked it. And I also need to get all the flux cleaned off of it too. So let's see about what temperature this is running at. That's about 60, so that should be fine for me to turn it on. Okay, go ahead and plug it in. And would you look at that? We get a fan spin. Isn't that beautiful? So there we go. Well, looks like this board was able to be fixed. So let me quickly go over what I did real quickly. So, first thing was we had quite a bit of corrosion in this area over here. So we had to replace all of those components and clean all that corrosion off. Next, what we did, which of course I'll test this after the stream when I get the computer put back together. In this area over here, we had a component that had completely corroded itself off of the board that we replaced, and we cleaned up some corrosion there. We moved this chip back into place, since either from the factory or from someone else working on it made this chip super crooked, so we fixed that. And we also fixed a short on PP3V3S5 from this little capacitor right here. And now because of that, we have a beautiful fan spin on a hopefully fully functional board, which I will get to test right after I finish this stream. But not before I get to finish this other board I have to work on, which, as much as I like streaming board repairs, I already know this one's not going to be fun. So yeah, this next one isn't going on stream, but I hope you guys enjoyed this stream, and I will see you again next time.